Okay, so here we have everything in nature changes. Examples include climate change in the phase of the moon, change in populations. To describe natural processes mathematically, the ideas of change and rate of change are often used. Instantaneous rate of change. This is asked for all the time on AP exams. It's asked all the time. Instantaneous rate of change is the rate of change at a certain instant, like 2 seconds, 4 seconds, 8 seconds. It's instantaneous, okay? Instantaneous rate of change, what you need to know is that's tangent slope, not just slope. Remember I told you rate of change is slope, right? Average rate of change is slope. We agree? Instantaneous rate of change is actually tangent slope. And what's the tangent slope the same as? The first derivative. So it's asking you to find the first derivative. And then plug in x, whatever instant they give you. First derivative. So instantaneous rate of change, you're going to find the tangent slope. And then if they want it at 3, you plug 3 in for x. If they want it at 7, you plug 7 in for x. If they want it at 4, you plug 4 in for x. Okay? The instantaneous rate of change at f at c is the limit as x approaches c of the average rate of change. The average rate of change is your normal slope. If you take the derivative of that, you get your instantaneous rate of change. So average rate of change would be just fill it into the slope formula. Instantaneous rate of change, determine the first derivative, then plug in. Only way we know how to do the first derivative right now is Newton's first principles. That's it. That's all. Okay? We'll go through other ways too, but that's the way we know now. Symbolically, it follows the same formula as determining the tangent slope or the first derivative. So that's why I wrote up there tangent slope or first derivative. Okay? So here it says finding a rate of change. I think this one's missing, but I printed it from the... Yeah, you guys have everything. Mine is... I put it up as a Word doc instead of a PDF, so it kicks out the equations, but it's in front of your face. So it says, find the instantaneous rate of change of the function. It's going to kick out all my functions, but that's okay. F of x equals x squared minus 5x at 2. So what we need to do is we really need to just find the first derivative, correct? How do we find the first derivative? We plug it into Newton's first principles, which is this big bad boy over here. Okay? We already have f of x. We need f of x plus h. We agree? So I'm going to go up here and write it up here. So I'm going to go f of x plus h. All you do when you find that part is you plug x plus h into the f of x equation for all the x's, correct? So we are going to go x plus h squared minus 5x plus h. Now, x plus h squared is not x squared plus h squared. X plus h squared is x plus h times x plus h. So you're going to get 3 terms, correct? Every time you do a binomial squared. So I'm going to get, and if you can't do this in your head, write out x plus h times x plus h in FOIL. Okay? So I'm going to get x squared, and then xh plus xh. So that's plus 2xh, and then plus h squared. And then I distribute minus 5x minus 5h. I'm trying not to show every single little step like that one. If you have to write it out twice and then FOIL and get the little step, good. Profs will not show that little step. Okay? So I don't want you to be lost because I show every tiny, tiny step when you go to a prof. So I'm explaining what I'm doing, but I want to show you how they would do it. They wouldn't span that. So for you, if you need to, write it as x plus h, and then you get x squared plus xh plus xh plus h squared. Then you're going to get x squared plus 2xh plus h squared, right? See how I just did that? They'll just do it right from the binomial. Okay, so we have our f of x, we have our f of x plus h, we have everything we need in order to find the first derivative. We agree? So, we're going to do a first. We're going to do, this is an f of x function, so I'm going to find f prime of x, which means I'm finding the first derivative, which means I'm finding the instantaneous rate of change, right? If I want instantaneous rate of change, it means find the first derivative. So I write it as f prime of x. If I take f of x and I plug it into Newton's first principles, I get f prime of x. That is what happens. That's what you do. When you plug it into here, you get the first derivative. Okay? So it's going to equal the limit as h goes to 0 And then I have f of x plus h first. So I get x squared plus 2xh plus h squared minus 5x minus 5h. And then what do I have to do? Minus f of x. So when you minus f of x and it's a binomial, you're actually distributing a minus sign into both, correct? So I'm going to minus x squared and minus 5x. So when I minus x squared, I get negative x squared. And then I'm going to minus a negative, so I'm actually going to get positive. And how do you know you didn't make a mistake? Everything without an h will cancel off. And if it doesn't, you made a mistake. Often it's in just distributing the minus sign. Or sometimes it's in your expanding your x plus h. So you should feel confident or not after this step. So it's either going to all the x's will cross off and you're like, boom, I got this, or they won't and you'll be like, uh-oh, what did I do? You'll at least know to go back and try again. So I'm going to cross off the 5x and the negative 5x, the negative x squared and the positive x squared. And now I have 2xh plus h squared minus 5h. They all have h's, which is good. Because now I can GCF an h out, and the h's will cancel off, and then my problem is gone, right? My biggest problem here is h is on the denominator, and if I fill in a 0, I'm in trouble. So I need to get that h to go bye-bye. So I'm going to get limit as h goes to 0. And now I'm going to take an h out of all three of these terms. So I'm going to get h. And then 2xh is left with 2x. Plus h squared, I take an h out, I'm left with h. Minus 5h, I take an h out, I'm left with 5 over h. Now the h's cancel off, and my problem is gone. And once my problem is gone, I can do, I can fill in. I can do direct substitution. I can fill in my substitution. I can fill in my h now for 0. And why can I fill a 0 in for my h? Because filling in a 0 for my h doesn't cause problems anymore. I got rid of the problem. So I'm going to have 2x plus 0 minus 5. And so I get 2x minus 5. Now this, if you want to write it down for yourself, this is the general instantaneous rate of change. Why is it the general one? Like the general solution for arithmetic series or geometric series. Why is this general and not actually the answer at 2? Yeah. Because it works for any x value. I haven't plugged anything in, right? So this is my general instantaneous rate of change, 2x minus 5. After this, I can literally find anything like that. What's it at 1? 2 times 1 minus 5, negative 3. Okay, what is it at? And I can keep going, right? I can find things really, really quickly now. So I'm actually not done because they wanted the instantaneous rate of change at 2. So how do I show that in function notation? Instantaneous rate of change is f prime of x, correct? We agree? But I want it at 2, so what am I going to write? F prime of 2. So I want f prime of x, I'm going to write it out here for myself. That's just equal to 2x minus 5. We found that. Bless you. But I want f prime of 2. And that's the function notation to show them, hey, I'm finding the first derivative at 2. I'm finding the instantaneous rate of change at 2. That's their function notation to show that. And now I just plug 2 in for my x. And I get 2 times 2 minus 5, which is negative 1. And you'll find out when we get to word problems and such like that, that negative 1 is like just the direction. Like you're not going negative 1 miles per hour. You're going like left 1. You know what I mean? It's like in physics. It means direction is what the negative sign means. Okay? Also in this case, it's just the slope. The slope is negative 1. It's not a word problem, so I would have a slope at negative 1 when I'm at 2. The straight line. So you remember how I drew lines over here? This would have like a slope of, let's say, up 2 over 3. So let's say it's 2/3, right? So that I would know the slope of that straight line. This one has a slope at negative 1 for that instantaneous rate of change. Now B says any real number C. So we just do f prime of C, which gets us 2c minus 5. Done. Okay. Then we'll go to the question below it. So So here we have finding the rate of change in a biology experiment. So it can be used in any type of bio experiment or something like that. You can see where they could use it in real life. So here it says, in a metabolic experiment, the mass M of glucose decreases according to the function, and the function's not there, surprising, M of T equals 4.5 minus 0.03 T squared. Now, if they give you a formula just like in 30-1, they have to tell you what the variables stand for, right? They can't just give you a random equation and then not tell you what it stands for. So here it says M is the mass of glucose decreasing according to this function, so it's a mass decreasing. And then here it says where M is measured in grams and T is time in hours. And then they want you to find the reaction rate M prime of T at 1 hour. So what do they really want you to find here? The first derivative, and then they want you to plug in 1. Okay? Try it out. So you're using this. They want the first derivative, and they want you to plug in 1. Don't even know. All right. So when we fill it in, we're going to get the limit as h goes to 0 of 4.5 minus 0.03 t squared minus 0.06 th minus 0.03 h squared. And then I have to subtract f of t, so minus 4.5 and then plus 0.03 t squared. All over h. So anything with t's now needs to go away because t's are just x's, right? So 4.5 and 4.5 need to go away because they don't have a t, they don't have an h. Anything without an h needs to go away technically. And then 0.03 t squared and positive go away. And so then I'm left with the limit as h goes to 0 of, take an h out, and I'm left with 0.06 t minus 0.03 h all over h. When the h's are gone, my problem is gone. So I can plug 0 in for h. Yep. So I get negative 0.06 t minus 0.03 times 0, which equals negative 0.06 t. So I'm going to rewrite that as m prime of t equals 0.06 t. So that's the tangent slope for the instantaneous rate of change at any t, correct? But they want it at 1. So we get m prime of 1 equals 0.06 times 1, which is 0.06. Now, you have to keep in mind it's a rate of change. I just dropped the negative off, is that what you're saying? Now, it is a rate of change. So rate of change, whenever you find first derivative, it's something over something. Because you'll always have like grams per hour or kilometers per minute or whatever it may be, okay? Because it's your rate of change, it's something over something, just like slope would be. So your y comes first over your x, correct? Well, my y in this case is m, and what is m? Grams. So this is g per time, which is hour. Well, and it says the mass of glucose decreases. So what does that minus sign just mean? It's decreasing by 0.06 grams per hour at 1 hour. That's its instantaneous rate of change. So it makes more sense sometimes when it's actually in a word problem. And there's this question. Okay, then we have the average velocity. For some reason, it's dropped down there instead of at the top, whatever. So, it says here, finding the average velocity. Whenever you see average instead of instantaneous, average just means slope. Instantaneous means tangent slope for first derivative. Very different. Average, instantaneous. Average, instantaneous. So, here it says average velocity provides a physical example of an average rate of change. For example, consider an object moving along a horizontal line with the positive direction to the right, or moving along a vertical line with the positive direction upwards. Motion along a line is referred to as rectilinear motion. The object's location at time t equals 0 is called its initial position. The initial position is usually marked as the origin on the line. So if we look at average velocity, average velocity is the signed distance s from the origin to time t of an object in rectilinear motion. It's given by the function. If at time the object is at, and at time the object is at. Why is this still, oh, because I'm not on this one. Ignore me. Let me go to the one that actually I PDF'd. It's ignoring all the numbers, which is really stupid. Okay. There we go. So the signed distance from the origin at the time t of an object in rectilinear motion is given by the function s equals f of t. If at time 0, so that means the initial position, the object is at s0 equals f of t0. And at time 1, the object s1 is at f of t1. So basically they're just making s, they label s as the distance for some unknown reason instead of d. They often use s. It's just the distance. So if I want the distance at 0, s of 0, I just fill in t at time at 0, right? And then if I want s of 1, I fill in time at 1. So here it says then the change in time is delta t, so t1 minus t0, and the change in distance is s1 minus s0. Now equals f1 minus ft0. The average rate of change is this, and it's called the average velocity. Do you know what this is? Slope. It's change in s, which is change in the distance, bless you. So you just fill in the times and get the y's. And this is change in t, fill in the times. This is slope, written in a really convoluted, make you freak out in a way. It's just slope. This is just, bless you, m equals y2 minus y1 over x2 minus x1 in function notation, right? F of t1 is just y when x is t1. And this is y when x is t0. This is x is t1 minus x. It's literally slope, written in a funky way. That's all it is. So if you want the average velocity, if it ever says average velocity, don't know what I was going to write there. Average velocity equals, technically, I'm going to keep using function notation because function notation is correct, but I'll use x's as normal. It would be f of x1, or x2, let's say, minus f of x1 over x2 minus x1. It's literally just slope. Don't overthink the question. Do you know how you did slope in grade 10? All you did was you found two coordinates, you labeled it x1, y1, x2, y2, and then subtracted them. Correct? That is literally all we're doing in all this words of greatness. Okay? So let's look at this question. Finding the average velocity. The Michael Callahan, Pat Tillman Memorial Bridge spanned the Colorado River, opened on October 16, 2010. Having a span of 1,900 feet, it is the longest arch bridge in the Western Hemisphere, and its roadway is 890 feet above the Colorado River. If a rock falls from the roadway, the function s equals f of t equals 16t squared. That is the function that works for just if a rock falls. It gives the distance s in feet that the rock falls between 0 and 7.458. Why would they give this? What is that? Why did it stop? Because the rock hit the water. At what time, guys? 7.458 seconds. It comes later, don't you worry. All right. Because this is a parabolic rock throw, it goes by 6t squared, and it starts at 0, and 7.458 hits ground. So here it says, here, 7.458 seconds is the approximate time it takes the rock to fall 890 feet into the river. The average velocity of the rock during fall is. Average velocity. I could give a crap about what the rest says, and I'm recording crap, and I said it twice. Whatever. I'm a rebel. Okay. I don't monetize my YouTube video. You are the only ones who watch it, and I don't even think you guys do, so it's fine. Average velocity. If you see average velocity, you should immediately go, hey, Mrs. Lepp wants the slope. That's all she wants. Shh. And the giveaway is the word average. Instantaneous means first derivative. Average means just find the slope from grade 10. How do I find slope from grade 10? I need two coordinates, correct? I have x values, do I not? What are the two x values? What are the two x values? 0 and 7.458. So if I do f of 0, I'm going to go 16 times 0 squared, which is 0. So I'm at 0, 0. That was a rough one. Okay, then if I do f of 7.458, this one gives me a really weird decimal. 16 times 7.458 squared. Now, just so you know, randomly lately, the AP exam randomly sometimes asks for like a rounding to like the 10th. Because it used to be like, they always want you to round to 3 decimal places. Then just recently they threw like a rounding rule in one question. I was like, why are you changing it up, peeps? So if they do not give you a rounding rule, which majority of the time they do not give you a rounding rule, it is set in AP that you always round to 3 decimal places. Always. So the only time you don't is if they're like to the nearest 10th, which they just started randomly doing on random questions. So, I don't know. So the written response often has no rounding. I've never seen it have a rounding rule, to be honest. You just round to 3 decimal places always. If you don't, they'll dock you, because that is the rule in an AP exam, except for when they started doing now random rounding rules. Sporadically. Okay? So, when we plug this in, we get, I don't have this memorized. You get 889. Stop rolling over.
Do we have to write it in the formula, like given, or should we just write, like if you're writing it out, like like x2 minus x1, because it's the same thing.
I would just not write the formula out and fill it in.
Okay. We don't even have to.
Right. Okay. So this is 7.458 and then 889.948224. So my x1, y1, I'm going to make be this one because it comes second. And then this would be x2, y2 because subtracting 0 does nothing. So that's why I'm putting those ones second. Right? Mm-hmm. You can flip-flop them. You just get a negative divided by negative, which would still be a positive. It doesn't really matter. So if I get average velocity, I want to give myself some space. I'm going to go average velocity. Oh, it switched. Okay, so I'm going to get y2, which is 889.948224 minus 0 over 7.458 minus 0, which gets me 119.328 feet per second, and often they write it out. So I'm going to do that because I'm a rebel. Now, why is it feet per second and not second per feet, which is stupid sounding, but why would it, other than the fact that it's stupid sounding, why do we go feet per second? Yeah? What numbers are on the top? Ones with feet. These are the feet, and these are the seconds, so it's feet per second. There we go. Okay, carry on. Yeah?
Why are we like solving for the birthday?
Why are we solving for numbers they give? Because we didn't pick 890. We have 889 point blah, blah, blah. It wouldn't end up in the same 3 decimals, and you would be wrong. That was vicious. No, the question rounded, and then you need to be smarter than the question. Okay. So if I give you instantaneous velocity, what am I asking you to find? The first derivative. So if I ask for instantaneous velocity, I'm actually asking you to find the limit of, this should not be here, erase that, I have it in my notes crossed off. I'm making you, no, that should be there, ignore that, check it, because here's the change in S over change D. So what I'm actually doing when we're doing Newton's first principles, guys, what we're actually doing is we're finding the limit of slope. This is slope, the change in slope. That's what that is. So we really are just finding the limit of slope. But I will just, because that confuses you, say do Newton's first principle, I get the same answer. So, because Newton's first principle finds the limit as h approaches 0 of slope. So here we're going to have instantaneous velocity. I want you to find the velocity of the falling rock at 1. Now some people will say, how do I know that's instantaneous? It's at an instant. What's the instant? 1. It's indirectly telling you instantaneous velocity without saying instantaneous velocity, right? If it says determine the velocity at the instant 1, you are finding instantaneous velocity because it's at the instant of 1. Yes, okay, good talk. All right, so we are using the formula from yonder. F of t equals 16t squared. So I want to find f prime of what, technically? 1 is what I'm ultimately finding, correct? So I need to find f prime of t first, which is, if I want to write the formula, limit as h approaches 0 of f of t plus h minus f of t all over h. What's the only thing I don't have? T plus h. So I do f of t plus h equals 16 t plus h squared. So it equals 16 t squared plus 2th plus h squared, which is 16t squared plus 32th plus 16h squared. So I'm going to get f prime of t, which they can call v of 1, because it's just the velocity at 1, right? They can also call it that. V of 1 equals f prime of t equals the limit. Not v of 1, it would be v of t, sorry, because we're not filling in a 1 yet. V of t. So we have the limit as h approaches 0 of that lovely equation, 16t squared plus 32th plus 16h squared minus 16t squared, because that's f of t, all over h. And anything without an h, better go gonzo alfonso, or we screwed up. Boom, boom. Take out an h. And we're left with 32t plus 16h all over h. The h's cancel, and I get 32t plus 16 times 0 equals 32t. That is not 32. And what do I want? 1. So I'm going to go off here, and I'm going to go up, actually up here, and I'm going to go 32 times 1. So I get 32 what? Whoa. Feet per second. No beats. Zip it, Lucas. Okay, then B just wants it at 7.4. So now I just plug in 7.4. So once you have it, it's quite quick after that. So now I'm going to go f prime of 7.4, which I could call v of 7.4. And then that equals 32 times 7.4, which is something. Numbers. 6.8 feet per second.
So, like, without the rounding rules, we have to write like 8.0 or...
Nope, you only have to round to 3 decimal places if you have to round.
Oh.
Will the document rectify for being correct?
Number? Yes.
If I put feet per second as a way to be funny, would they?
Yes. No. They would think you were dumb because they don't actually. Well, they don't know you. They don't know you're trying to be funny. They're just marking it and they're like, this person is dumb. No. They'll be like, ha ha ha, and then take a mark off. So it's not worth it. Okay. And then.
Wait till you take the
Yeah, feet is fun.
It's not that funny.
Hilarious. I'm going to use it as a joke on the weekends. All right.
I'm so.
So you have to try the 3, I think there was 3 of them that were boxed, maybe 4. So the homework would be, I have to type it up anyway.
This is what the new job marks classification.
Yes, because we've had this conversation. Okay. Your homework on here is, you would have had problem 19, and then AP practice prob 3, and then you would have had 43 as a problem, and then you would have had AP practice problem 7, and then 31 and 33. So you have, just so you know, 4 problems and 2 AP problems. So the problems are 19, 43, 31, 33, and the AP practice are 3 and 7 for tomorrow. I'll put them in your Google Classroom.